Alright guys, today we're going to look at partitioning a line or directed line segments. You can think of it in both of those ways. First, I can find a point on directed line segment using a specific ratio. So, just a little warm up. A 1/3 plus 2/3 equals 1. And then 2/5 plus 3/5 equals 1. That's just kind of a way you're adding the two line segments together, and you'll see that in just a moment. Key points. A directed line segment is a line segment from one point to another point on the coordinate plane. Directed line segments have both length and direction. The components of directed line segments, A, B, are the run, x2 minus x1, and the rise, y2 minus y1. Alright, pay careful attention to the beginning and the end points of the segment. Direction matters. For example, PQ and QP below have the same length but different directions. If you notice, if you go from Q to P, you're going left and down, which is negative. If you're going from P to Q, you're going right and up, which is positive. The route from Q to P is run of -4 and rise of -2. So it'd be -2 over -4, which is 1/2, would be my rate of change. In dividing a line segment into a given ratio, you need to first determine the number of parts. The line segment is divided into a 3:2 ratio, which has 5 parts. You just add the numerator and the denominator. A line segment divided into a 3/5 ratio has, the 5 ratio has 5 parts. Alright. Determine the total number of parts of the function, number of parts and direction starting point. Find the total length of the segment, divide by the number of parts to see how to divide up the sections. Start at the beginning point, count over the desired number of sections specified in the ratio. So right here is example number 1. Have T is at -8, R is at 6. So we're going to find C, so that TC is 3/7 of TR. So right here, my total length from -8 to 6, you just add 8 and 6, it'd be 14 for our total length. Well, number of parts out of 3/7 is 7, so we're going to divide 14 by 7 and get 2 sections in each part. Notice we have marked off the sections in each part, and we know we want to go 3/7, so we go over 1, 2, 3, and notice that our point here is going to be -2, so we went over 3 out of the 7 parts. Alright. W is at -15 and D is at 27. So the directed line segment WD is at 3/4 ratio. Now this time we're going to find the total length. So we had 3 and 4, our ratio. We get 7. And then I'm going to figure out my total length here. That was our number of parts. Our total length would be 27 plus 15. Which gave me 42 for the total length. Even though it's negative, we still got to get the total length. So we divide 42 by 7, and we get 6 equal parts. Now, we know is the ratio of 3 out of the 7, and we know that the 3, there's 3 parts of 6, so we're going to go over, from -15 we go over 6, to -9 we go over 6 more, to -3 we go over 6 more, to +3. So that tells me that my point R is at +3. Alright, let's look at another one. Determine the total number of parts from a ratio and the direction. Find the total for the rise and the total for the run. Divide the rise and the run into the correct number of parts using the ratio. Start at the beginning point, count the desired number of sections, find the centered pair. So right here, I'm going to find the point Z. So the rated line segment AB is 1:3 ratio. Now we're going to add 1 and 3 to get the total of 4. If we look at our graph here, we have our line, we count our points. Our rise is 12 and our run is 8. Alright, so right here, if we divide 12 and 8, we're going to get our sections that we need. So first of all, we know it's 1 out of 3. Alright, so we know it's 1 out of 3 sections. And as soon as you figure that out, you can kind of figure out where you need to put it at. But so we start at point A. We know we're going to go one section. So if we go one section of this graph, we're going to go down to this section and down to this section. Now our sections here, if you notice from our graph to our points here, we know that 4 goes into 12 3 times. So we know we're going to go down by 3. So we went down by 3, down by 3, down by 3. And we know 8 here to go over by 2. Alright? So 4 divided by 8 is 2. So we're going to go over 1, 2, 2. So we're going to go one section. Our point would be 1, 6. That's the way to do it with a graph. Now there's a formula too. Notice I took my rise and my run. My rise and my run. We go down 12, so that had to be a negative 12 for my rise here. So I started negative 1. This is my first x value because we're going from A to B here. Now we know that our actual part over whole here, it's called a K, alright, is 1/4. So what I'm going to do is I'm going to multiply 1/4 times my rise and my run to figure out my new rise and run to get to my new point. So I multiply 8 times 1/4 and I get 2. Alright. And then I multiply negative 12 times 1/4 and I get negative 3. So now I have my new rise and run. So all I gotta do is add that to my original x and y value. So negative 1 plus 2 is 1. 9 minus 3 is 6. And notice I get the same exact answers whether I use the formula or whether I use common knowledge with the sections here. Alright. Same thing with the number line. We marked off our sections. Either way, it's the same. Okay, right here, just more practice with the formula. If I have the order pair 3, 4, and 16, find the rate of change with a 3:2 ratio. I know that my total number of parts here is 5 total parts. Alright, so first thing I gotta do is I gotta find my slope or rate of change. So I'll use y2 minus y1 over x2 minus x1. Alright, and so let's say 10 minus 4 is 6, and 6 minus 3 is 3. So that's my original slope. Now, I have to find my new slope to find my new point. Alright, so I want to find the point that is 3/5 away, alright, from 3/4. Okay, so I'm going to multiply my run times 3/5 and multiply my rise times 3/5. So 3/5 times 3 is 1.8, 3/5 times 6 is 3.6. And then all you got to do is add that to your original x and y, which our original x and y up here was 3/4. We get 3 plus 1.8 is 4.8, and 4 plus 3.6 is 7.6. That's where my point is. It is 3/5 away from 3/4. Method 2, same problem. We're going to use a formula. Notice all we did was put our x2 minus x1 and y2 minus y1 in here. Now k is just my part over my whole, or my part over my total parts. So I take my original, where we're starting at, point A, if you want to call it. Alright, and then I use K. And I'm just going to multiply that 3/5, same thing we did earlier. 3/5 times 3 is 1.8. And then we do the same thing, 10 minus 4 is 6. 3/5 times 6, 3.6. Add 3 plus 1.8 and 4 plus 3.6, and I get 4.8 and 7.6. Alright, finish the work time and bring it in tomorrow to review.